Hi there. Today we're going to be looking at compound interest. So this is actually the most useful topic in the entire math syllabus, in my opinion. Yeah. So the question we'll obviously often get asked as teachers is, when am I going to need it in life? This topic you'll need all the time. Yeah. Whether you're saving money or you're buying a house or you're buying a car. Um, the world around you, compound interest is everywhere. So I'm not going to do this one from the exam question point of view. I'm going to play around with some situations and actually look at compound interest. Yes, so let's say we invest some money in a bank. Yeah, this is something everyone's going to want to do at some point in their life. And the bank gives you an interest rate of 4%. Per annum, which means yearly. So each year you get 4% interest on your money. Yeah. So what happens is you get interest upon the interest. So say we invest £10,000. Yeah. So how do I get my calculator up? There you go. So to find 4% of that, we just need to times by 0.04. Yes, so if I do 10,000 times 0.04, I get £400. So after 1 year, I'm going to have £400 in the bank extra. And I'm going to get, after that year, another 4% on that. So I will have, so I've got 10,400 in the bank. So after 2 years, I will have 10,400 times by 0.04 extra. So £416. So I will have £10,816. So this interest rate will go up and up. So in the next year, so not the interest rate will stay the same, but the interest payment will go up and up. So if I do 10,816 times by the 4%, I'll be getting an extra £432 and 64 pence. So that is compound interest. It is interest upon interest. So if we were asked to find the amount in the bank after 1 year, that would be the answer. They asked after 2 years, this would be the answer. And you could see how we would have got 3 years. What if they asked for after, or what if we imagine we want to calculate, yeah? How much you have after 10 years. Well, this process, I think you'll all agree is a little bit tiresome or laborious. So what we could do is do the investment amount multiplied by the multiplying factor to increase by 4%. So the decimal to increase by 4% is 1.04. And if we want it after 10 years, we would do to the power of 10. So after 10 years, we would have 10,000 times 1.04 to the power of 10. We've got that £14,802 and 44 pence in the bank. That is compound interest. Obviously, there could be a variation of how the question is asked, but that is what you do. Yeah, so if we look at a house price, for example, let's say I buy a house for £250,000 and I'm wondering, what's it going to be worth in 25 years? when I finish paying my mortgage payments, and I take let's take a 2% interest rate over the next 25 years, that's what I would have to type into the calculator. Yeah, so that 1.02 represents a 2% interest rate increase. So now we type that in, 250,000 times 1.02 to the power of 25. So my house will be worth, in this scenario, £410,151.50 in 25 years' time. So even though I would have overpaid on the amount I've borrowed over 25 years, what I'll be getting in the end will be most likely to be worth more. Yeah? So that is savings and mortgages. That's where compound interest is most useful. So a house is your biggest purchase in your life. What would be the second biggest financial commitment for most people? Yeah, a car. Unlike houses, which appreciate, they go up in value, what happens with cars? Exactly, they depreciate. So let's say we buy a car for, let's say £20,000. And let's say it goes down by 20% per year. So that would be a decimal of, to reduce by 20%. Yeah, we'd have 20% less than the original, which is 80%. What's the decimal for 80%? Exactly 0.8. So let's say we wonder how much that'll be worth in 5 years. Yes, so we would do no, I need to clear some of my screen. There you go. So let's do 20,000 times 0.8 to the power of 5. And that is not very much, 6 grand. Obviously, it doesn't matter because you've used the car. And maybe when you bought it, you had no reason to want to sell it. But after 5 years, it's going to be worth a lot less. Maybe we wonder, well, how much will it be worth after 10 years? So after 10 years, let's give that a go. So we would do 20,000 times 0.8 to the power of 10. For £2,000. £2,147.48 after 10 years. So it's a basic calculation you can do, depending, when you buy a car, you want to have it for a certain amount of years. Maybe when you're young, you're buying one, you want it for 2 or 3 years. When you're older, you're looking for something for 10 or 15 years. And it's just something that you need to understand and be able to use. Yeah, so to make those financial decisions. So that was depreciation, yeah? So often you'll get questions about depreciation, which just simply means going down in value. So the third example I said at the start, where we'll see it in everyday life, I'm going to use is disease. So has anyone ever heard of something called the COVID-19 coronavirus, I think? Yes? So why was that worse than the common cold? Common cold versus COVID-19. Well, the common cold, is said that people spread that to between 1 and 2 people. Yeah, so when you get it, you spread it to, say, 1.5 people. So surprisingly, someone sneezing away seemingly on everyone, they are spreading it on average to about between 1 and 2 people. COVID-19 was rate of spreading was between 2 and 3 people. So let's say 2.5. Yes, if you've got one person who starts with it, they'll spread it to say 2 people who will spread it to say another 2 people and another 2. Whilst COVID, one person might spread to 3 people, who will then spread to 3 people, and so on. For me, that doesn't sound like that big a deal. But let's have a look at the numbers. If we do 1.5 to the power of 10 versus 2.5 to the power of 10, let's get rid of that first, versus 2.5 to the power of 10, what do we get? Let's have a look. So we have 1.5 to the power of 10 would be what? About 58 people. So we're saying that after 10 phases of spreading, 58 people have got this cold. Well, if we do the coronavirus, like I say, mathematically, it's not much different. It's just 2.5. Like I said, to me, it doesn't sound like a huge amount. You know, someone Sneezy McSneezerson is still just coughing everywhere. They are only giving it to probably 2 or 3 people. Look at that. After 10 rounds of spreading, that's gone to 9,536 people. Yeah. Maybe we do it to the power of 15. Let's have a look at that. So 1.5 to the power of 15 is 438. 2.5 to the power of 15 gives us, look at that, we're pushing 1 million. So we've got 931,322. Should have rounded that up to 323. So 931,323 people, roughly. So that is just compound interest, yeah? It is a growth model. So look, we've looked at money, things that go up in value, like savings, things that go down in value, say a car, and just, you know, spreading of the common cold versus COVID. I hope that's been useful and that you've enjoyed it. I've been Mr. Raz. Thank you.